These are the two problems that were asked for the FAQs for section 8.2, day 2. It says, for an ellipse that generates the ellipsoid of a lithotripter, the major axis has endpoints at -8, 0, and 8, 0. So those would be the first things that I marked down here. And it did say that that was the major axis, which really it makes these the vertices. So if those are the vertices, we are supposed to keep going with this. And it says one endpoint of the minor axis is 0, 3.5. That would be covertices, and obviously equal but opposite. Below that, we have those covertices. So it says find the coordinates of the foci. Well, the distance from the center, which is obviously halfway between -8, 0 and 8, 0, and that's 0, 0, that's going to help us figure out A, because this is that distance A, and that's 8 units. And B is that distance from the covertices to the center, and that's 3.5 units. So what they want us to do is figure out from that information what C is, and of course with the ellipses we're going to use C squared equals A squared minus B squared. So C squared equals 8 squared is 64 minus 3.5 squared. Well, 3.5 squared is 12.25. So C squared will equal 51.75. And if we take the square root of that, we will get 7.194, blah, blah, blah. All right, so what does that mean? Well, in an ellipse, remember that the foci are inside the ellipse, and they are on the major axis. So a little bit more than 7, here we have a focus, and here we have a focus. Now, the lithotripter works from the fact that when you have the full ellipse, switch colors here, it is. When you have the full ellipse, whatever bounces off this focus will hit the ellipse and then go to the other focus. Well, that means that's where our lithotripter needs to be at, and this is where the person's kidney or whatever it is that they're trying to break up the calcium deposits in needs to be. So how to describe that? Well, probably easiest to just say they both have to be the square root of 51.75 from each of the ends, because that's where the foci are. So the coordinates of those foci would be plus or minus 7.194, 0. Now, I believe the book left this perfect, which isn't a bad idea, and just said, you know what, let's put the square root of plus or minus the square root of the 51.75, 0. And that's again because if they want this accurate, they're going to keep going and they're going to figure out exactly what distance they need to have that. But you can, like I said, just explain this to somebody by saying, once you find the center, you need to go approximately 7.194 units in both directions. And on one end, you will put the person, and on the other end, you would put the lithotripter. Then number 60. Both of these were about lithotripters. I thought maybe I double copied that one. Lithotripter in this one. A lithotripter shape is formed by rotating the portion of an ellipse below its minor axis into its major axis. If the length of the major axis is 26 inches and the length of the minor axis is 10 inches, where should the shock wave source and the patient be placed for maximum effect? Oh, for goodness sake, this is really a lot like the last problem that we just did. So we certainly could sketch it out and say, all right, major axis is 26. We don't know if it's horizontal or vertical, so we'll take the easy way out and make it horizontal and go 13 out in each direction. I'm going to make these go by 2s. So 2, 4, 6, 8, 10, 12. There's our 13. 2, 4, 6, 8, 10, 12. And that's our major axis. So that means that this distance is A. Minor axis is 10. Well, then that means we would go 5 up and 5 down. And I think I can still go by 1s this way. But now that'll give us B. So our center is obviously 0, 0, and either one of these will give us our B value. So we've got A at 13, and B at 5, and C squared equals A squared minus B squared. So C squared equals 13 squared minus 5 squared, which is 169 minus 25, which happens to work out very nicely to 144. So that means C is 12. So how do we use that? Well, that means those foci are 12 units from the center. And that would be a great way to tell somebody where the patient needs to be and where the lithotripter needs to be, the shock wave source for the lithotripter needs to be. So we could say 12 inches from the center. And just because we want to be very plain about this, we don't know if this is horizontal or vertical. We should say 12 inches from the center on the major axis. That way they can set it up whatever way they need to, horizontal or vertical, as long as they know, hey, it's a major axis that they need to be 12 inches from the center on. So that's it.